Good evening. My name is C. Arvindan. Register number UR16CS136. So this is the video regarding the Casetools first experiment, that is use case diagram. So my given experiment is regarding the employee payroll management system. So this is what I have created. These are the actors: salary employee, the employee, administration system, and payroll. These are all the system which I am using over here, like checking the employee details, their working hour, identifying the designation and the leave, and finally generating the payroll to the bank system. So now moving on to the next file. So it's regarding the class diagram. So this is my class diagram which I have given. So there is an employee, finance admin, payout admin, and bank with login. These are all the properties and their functions which I'm using over here. So like for example, login is having attributes like username and password, and the function as get the login item, and bank is similarly having the properties like staff name and staff salary, and withdrawing the payout. Hourly and salary both are empty because in the later part I will be explaining regarding how the forward engineering is happening and reverse engineering is happening using these entities alone. So the second experiment is this class diagram. Now the third one is sequence. So this is the sequence diagram. So basically these are the three objects: either it can be employee, another one can be a payroll, and this can be a database transaction. So regarding it, the logging, the secure communication, entering the data, it is like a sequence wise. The same thing which we have explained in the use case diagram, the same thing is happening over here, but this time it is all in the sequential order, one after the another. So our fourth diagram is after sequence diagram, it should be the collaboration diagram. So directly we are converting the sequence diagram into the collaboration diagram. It's quite an easy part. So this is the collaboration diagram which I am showing you over here. So employee, database and treasury, finance admin, bank, and login payroll. So if you will be checking the sequence diagram of it, so this is a sequence diagram like employee, payroll, system, bank, and finance admin, and these are all the functions which is happening behind it. So when I am converting it into the like as a collaboration diagram, this kind of thing appears, where each and every number will be specifying like what are the procedures first need to be executed and later on which has to go on. So after our collaboration, it's state diagram. So state diagram is quite simple over here. So it tells like this is the start, this is the end, these are all the states. So this is like logged in, sorry. So if this is a state which is states as logged in, choice, giving a choice whether we have to see the data viewed or attendance marked, and it goes for the paying and updating in database, and finally printing out the employees payroll. So this is how a state diagram should look like, and afterwards the activity diagram. And inside the activity diagram, it's quite simple. It is almost likely like a state diagram, just a few notations are extra. So this is a start, this is the end part, these all are our states, these are decision making object constraints. So like logging in, authentication, if new employee is coming then he has to be enrolled, admin has the finance management over, and according to the post the salary whether it has to be incremented or low, those things are decided, and if the attendance is less, then deduction in payment is also happening, and updating the payroll if any changes are there, and then finally updation in the database and printing the payment. And the second last one is the component diagram. Component diagram is usually getting all the other components which are being used over here. So these are all our components, and these are the like devices, bank and portal which we are using. So this is admin, payments, and admin is having the company database. He can manage the bank and portal also. This is the payment, and in payment we can do the increment and deduction, updating the pay sheet later on, and then employee database has to be updated. Finally it has been reflected back to the employee, and finally pay slip has to be generated. And after that, the final diagram is our deployment diagram. In deployment diagram, it is all the devices which are using. So this is the company server. We are having database server, network interface, display, backup server, keypad, web server, printer, and login device. These all are the devices which we are using for constructing all these diagrams and models. So let's see the coding part where we are constructing. So this one over here is for the coding. So this is how the coding part looks like. So in the forward engineering, what we are usually doing is we are generating a Java code for the diagram, and that Java code can be later on converted into the real diagram. So we have to generate a Java code for the employee payroll system. So for that we have to go to this model and then add a profile, and that profile should be a Java, and once it is added, we can directly generate this code. And I have modified this class called hourly, and inside I have given 3 objects called minutes, seconds, and hours, and there is one function which is called as get_time. So this is for forward engineering, and when we are doing the reverse engineering, the same code can be generated. So let me show you for reverse engineering here. So after once we have given the diagram like the coding part for the object, this is how the object creates, say stating as hourly1 with these kind of objects and with a function. So that's all. This is how all the diagrams have been implemented inside the star UML application, and all the 10 experiments have been explained. And again, my name